We recently visited the first building in Manitoba, fully constructed of cross-laminated timber, and were impressed with the capabilities of this innovative construction material and led us to investigate it further. For as long as we can remember, shelters have been built to protect people, animals, and goods from the climate. Initially, human shelters were very simple and built from whatever materials were readily available. Some shelters were temporary, and some were more enduring. Over the years, structures have become more complex and more diverse in both the materials and design. One material that has been touted as having the potential to be the top material used across industries and the building material of the future and present is cross-laminated timber, commonly referred to as CLT. CLT was first introduced in the early 1990s in Austria and Germany. By the early 2000s, the popularity of CLT increased through its reputation as being a sustainable building material. The construction benefits of using CLT include sustainability, strength, faster construction times, cost savings, and a natural wood aesthetic. It has a lower carbon footprint than traditional methods and provides better indoor air quality and acoustics. CLT falls under the category of mass timber and gives wood the strength and fire retardant properties that rival steel. To create CLT, several layers of single boards of wood are glued together in alternating grain directions, creating prefabricated slabs. CLT slabs can be up to a foot thick, supporting up to a 100-story building. The slabs are designed to fit any specification, size, and dimensions, which opens up a wider range of design possibilities for architects. The prefabricated slabs are then shipped to the site and quickly installed by connecting the slabs. Where CLT will excel and provide the greatest contribution to the construction industry is with tall buildings. Since the Industrial Revolution, steel and concrete have become the norm for tall buildings. However, steel and concrete use more energy and emit more greenhouse gases and pollutants over their life cycle than CLT. For this reason, and several more, the growth of CLT in Canada has significantly increased. In addition, the Canadian government is committed to improving the competitiveness of Canada's forestry sector while mitigating climate change issues. Building with wood is one strategic way Canada can improve the economy while meeting its climate change target. These factors have led to Canada becoming the world leader in tall wood buildings. In 2016, the largest CLT building in the world was built on the UBC campus. It is 18 stories tall. In addition to tall wood buildings, remote northern communities have started to embrace CLT. Mississippiwistic Cree Nation, MCN, near Grand Rapids, Manitoba says it has purchased 30 new mold and fire-resistant homes. Mold has become a serious issue in remote communities, and CLT homes give hope to the community that they can live in a healthy home. Further benefits from the CLT home include the speed of assembly. Each house is estimated to take 3 to 4 days to put together, so it is also very quick. Finally, a recent article spoke about the historical relationship between Indigenous people and lumber through the connection to nature, making it the perfect material for Indigenous projects. Indigenous communities can also benefit economically from timber products, since the Manitoba government signed a forestry revenue sharing agreement in June 2023. CLT can be classified as an incremental innovation. It is a different way to construct houses or buildings. It leverages existing construction competences and fits within the existing construction business model. The primary difference with CLT is most of the framing of a building is outsourced to a production facility instead of the work occurring on site. CLT is currently in the growth stage of its S-curve. CLT is an example of a retrogression with the innovation dating back 30 years. Initially, timber was displaced by steel and concrete construction in favor of low-cost designs over the past few decades. The construction industry has sparked a resurgence of this innovation due to the demand of more sustainable construction solutions. Research and information about building construction and their sustainability is more prevalent than ever as organizations, individuals, and governments are becoming increasingly concerned with the impact their buildings have on the environment. CLT is poised to capture a lot of attention over the next several years, providing an excellent solution for sustainable construction. As time progresses, CLT is expected to become more popular as the need for housing is not going away anytime soon. Therefore, parties interested in CLT should pay close attention to not be surprised by any disruptive changes. CLT leverages the ecosystem service of forestry. The cradle-to-cradle life cycle of CLT is sustainable and regenerative in nature. Many CLT panel manufacturers source exclusively from 100% renewable forestry organizations to ensure consistency with their product offering from a sustainability perspective. The rise in popularity of this innovation will have implications for several industries. The construction sector will be positively and negatively impacted by CLT. Framing hours per project are drastically reduced when utilizing CLT, as opposed to more traditional construction methods. So, reduced installation time will mean less billable hours on job sites. However, The output of a framing crew or builder will drastically increase by leveraging CLT. Statistics show that one framing crew can install upwards of 10,000 square feet of CLT panels per day, far exceeding the averages of standard stick frame construction. The concrete and steel sectors will be negatively impacted, since CLT is a direct replacement for these materials on commercial projects, therefore decreasing their demand. The forestry and wood products industry will reap the benefits of the rise in popularity of this innovation. CLT uses roughly 50% more wood in comparison to traditional framing methods. Additionally, CLT provides the ability to increase the amount of wood used in a project in comparison to more traditional construction methods. The engineering and design community will experience an increase in demand due to CLT construction. The panel systems are all engineered, and designing these projects will become an additional revenue stream for individuals working in this sector. The planet also stands to benefit from the innovation of CLT. Wood, of course, is a renewable resource, and CLT is often specified in place of concrete or steel. Wood also has a significantly smaller carbon footprint compared to steel and concrete. Furthermore, CLT wastes virtually no wood. An average 2,000 square foot new home build using stick frame construction in the USA generates on average between 1,500 to 3,700 pounds of wood waste per project. Since CLT panels are engineered, assembled in a factory, and engineered to size, wastage is virtually non-existent. Another environmental benefit is the CLT panels act as carbon sinks, storing carbon for their lifetime. CLT is also significantly lighter than steel and concrete, therefore transportation emissions are reduced. CLT offers a compelling option for those involved in the building industry. The diverse use of CLT from a single home to a high-rise introduces a challenging decision based on location, sustainability, cost, and time. Having one of our group members make that decision themselves, it was an easy decision to make because of these factors. Like this decision, many have made similar decisions leading to considerable growth in the last several years, and will continue to make strides in the years to come.